Hello everyone and welcome to today's video. In today's video, we are going to discuss about insulating materials used in power and distribution transformers. So let's begin. The learning outcome from this video is we'll have an understanding about the properties required in insulating materials that are to be used in transformers. Secondly, various insulating materials that we use in distribution and power transformer. And finally, a brief introduction to the insulation aging in transformer. Introduction. Insulating materials play an important role in the proper functioning of any electrical equipment. Mostly, it is observed that the failure of insulation material is responsible for the failure of any electrical equipment. Therefore, for the satisfactory and safe operation of any electrical device, it becomes necessary and a crucial point to select proper insulating material. A good insulating material needs to have good mechanical and electrical strength and good thermal and chemical stability. Insulating materials that we use for transformer. The insulating materials used for power and distribution transformer should have good electrical properties so that they can withstand power frequency, voltage and impulse over voltage. They must also be mechanically strong in order to withstand electromagnetic stresses brought over in the event of short circuit and overloads. They must have good thermal stability in order to handle the heat produced during transformer operation, and also they should have good chemical stability in order to prevent its degradation during various operating conditions. Different parts of transformer has different insulating requirements. Hence, they have different insulating materials to serve the purpose. Sufficient insulation between different active parts of transformer is necessary for its safe operation. Adequate insulation is not only necessary to isolate the parts from each other, but also for the safety of transformer against accidental overvoltages. Hence, to understand it in a more proper way, we can categorize these insulation system of a transformer as follows. It has been basically classified into two regions. One is the major insulation region and other is the minor insulation region. So what all regions come in major insulation region? The insulation that we require between core and low voltage winding, between low voltage winding and high voltage winding. Thirdly, between top and bottom of winding and yoke. Fourth, between high voltage winding and tank. And finally, the bushings. And the regions that come under minor insulation regions are between conductors, between turns, between layers, between laminations, and finally between joints and connections. Let's see this in detail. Insulating materials that we use for these regions are: silicon material is one of the most commonly used insulating material in transformers. It is basically used in the lamination of transformer cores. Transformer cores are constructed from high permeable material made from thin silicon steel laminations. These thin laminations are assembled together to provide the required magnetic path with the minimum magnetic losses. The resistivity of steel sheet itself is high, thus reducing any eddy current loss by making the laminations very thin. These steel transformer laminations vary in thickness from between 0.25 mm to 0.5 mm, and as steel is itself a conductor, the laminations and any fixing studs, rivets or bolts are electrically insulated from each other by a very thin coating of insulating varnish or by the use of an oxide layer on the surface. The insulator material commonly used between the grounded core and the low voltage winding or the low voltage winding coil to ground between high voltage and low voltage coil is oil impregnated soil pressboard, paper, glass fiber, porcelain, etc. Solid insulation including pressboard or paper can have small internal voids, air voids. This reduces the insulating strength of the solid insulation as well as reduces its heat dissipation capacity. In larger power and distribution transformers, the conductors are therefore insulated from each other using oil impregnated paper or cloth. The whole core and winding will be immersed and sealed in a protective tank containing transformer oil. The transformer oil will act as an insulator and also as a coolant. Hence, it will provide an improvement to both the insulation strength and the heat dissipation capacity of the solid insulation. For this insulation and cooling, mineral oil or air or nitrogen can also be used. Oil wood is also used as a packing between core and coil. Insulation of bakelite is provided between the core and low voltage winding, also between the two windings, that is our low voltage and high voltage winding, and also between coils and yoke and high voltage limb and yoke. Transformer is basically placed in tank. Windings and other helpful devices are placed inside this tank. It is filled with insulating oil, that is mineral oil. It have usually cylindrical or cubical shape depending on the transformer construction, and it is coated internally and externally with color for safety point of view. Color coating provides protection in case of winding connection with tank accidentally. Heavy paper wrapping is also usually used on the leads coming from the winding. In this case, the insulation serves to reduce the stress in the oil by moving the interface from the surface of conductor where the stress is high to a distance away from the conductor where the stress is considerably lower. Again, the stress in the coil determines the amount of paper required, and the thermal considerations establish the minimum size of the conductor for the necessary insulation. For lead connections, PVC sleeves are also used. For insulation of conductor, fiberglass is also used. When transformer oil is used to impregnate solid insulation, the voids are filled with oil. In larger transformers, cellulose-based paper tape is usually wrapped over individual conductors. Layer-to-layer or disc-to-disc insulation is mostly provided by oil-impregnated kraft paper or even thick press board or transformer board in case of higher rating transformers. For insulation of connection wires at joints, crepe paper is used. For insulating the bushings, porcelain, phenolic bonded tubes, etc. are used. The bushings in the transformer are the insulating devices that allow an electrical conductor to pass electrical energy safely through it. It provides electrical field strength to the insulation of the conductors to withstand if large amount of electrical energy passes through it. Solid porcelain type bushing is used in smaller transformer, and oil-filled condenser type bushing is used in large transformer. Between turns, the insulation allows the transformer action to take place and the winding to function as planned. In insulation between layers, the material is interleaved between successive layers of an insulated conductor in the same winding. It is used in mechanical application only and does not serve an electrical insulation. For this purpose, rubber and acrylic polymers are used. Thus, we can understand so many insulating materials are required for the proper safe operation of a transformer. But even after that, our transformer with time suffers insulation aging. Now, what is insulation aging? The insulation system of transformer undergoes degradation with time due to the various operating conditions. Thermal, electrical, chemical stresses act on the insulation system during operation of the equipment to cause an irreversible change in the properties of the insulation system. Such aging stresses may cause either intrinsic or extrinsic degradation of insulation materials. In most insulation systems, extrinsic aging predominates because of the presence of imperfections and contaminants. Degree of insulation aging depends on thermal, electrical, chemical and mechanical stresses within the transformer. The temperature dependence of the insulation material plays a major role in influencing this effect, and this temperature of insulation depends on the loading pattern of transformer and on the ambient operating conditions. Other than normal aging, operational stresses are usually dominated by lightning strikes and short circuits. The windings of a new transformer are well clamped, so have sufficient mechanical strength. But as the insulation ages, the paper insulation shrinks, resulting in a reduction in clamping pressure, and thus the mechanical stability of the winding also gets hampered. Such mechanically weak windings will suffer from enhanced mechanical stresses due to forces arising from short circuit faults. Under high operating conditions, the oxygen dissolved in oil also accelerates the rate of degradation of solid insulation and oil, particularly in presence of water. The rate of thermal degradation of paper is usually directly proportional to its water content. At the time of manufacture of a transformer, the solid insulation is first dried out to a moisture level in the range of 0.3 to 1% and then impregnated and finally immersed in the degassed and dried oil. However, the water content of the solid insulation and of oil increases during the life of a transformer. This increase in water comes partly from the degradation of cellulose caused by high temperature and oxidation and partly from the ingress of water from the atmosphere. As the transformer breathes under different loading cycles, there is a chance that atmospheric moisture may ingress. So what can be solution? Basically, these power transformers are fitted with conservator to accommodate the increased oil volume. The conservator then exhales either directly to atmosphere or through dehydrating breathers. As the transformer cools down during low load cycles, the oil volume in the conservator reduces and the transformer breathes in through the breather. Silica gel present in the breather chamber will help to absorb the moisture from the ambient air as it flows in towards the conservator. The efficiency of silica gel type breathers depends on temperature and humidity of both air and desiccant together with the rate of airflow. Another type of breather known as freezer dehydrated or dry cold dries the insulation automatically. This also allows continuous drying of the air within the conservator. The water content of the transformer may still build up 2 to 5% over its lifetime depending on its breather system, loading cycle and design characteristic. But still, this solution does not handle the situation long. There is a need of proper diagnosis and maintenance of insulating materials in transformers to be done from time to time to ensure its safe operation. Studies are being conducted to find more effective and advanced diagnosis methods in order to understand the aging process and to have more advanced insulating materials which are able to have better and improve the properties in order to handle this aging phenomena and can ensure the life of a insulation system for a more long time as compared to one that we have now. So this was all about the types of insulating materials that we use in our transformer, the problems that they suffer due to insulation aging, and finally we have a discussion on the studies that are being made in order to tackle these solutions. I hope you liked the video. Thank you.